So for our first example of graphing a polynomial, excuse me, it is going to be f of x. Let's call this example 1. Negative x to the 4th 15 plus 5x to the 3rd plus 6x squared. All right. So in order for us to graph this, we have to know what the leading coefficient is. I'm just going to abbreviate. We have to know the degree. We have to know the end behavior. And it is nice to know the terms. It's not necessary, but it's a wonderful self-check to make sure we're doing it right. And then we need to know what the x-intercepts are and their behavior. Okay, so let me just kind of see if I can zoom in a little more here. All right, this is our first example. So for our first example, all examples, they're either going to be in standard form or they're going to be in factored form. It is so easy to tell if it's in factored form because it will have parentheses. Are there parentheses here? No, this is standard form, guys. So for standard form, the leading coefficient is just going to be the number in front. And the number in front is a -1. The degree is just the highest degree. It is written in descending order. The highest degree is 4. By the way, 4 is even. So here we go. And behavior. If it's a leading negative, we know it's going to be down on the right. If the degree is even, we know it's going to be the same end behavior. So the end behavior of this graph is down, down. Now remember, the number of turns is the degree minus 1. So 4 minus 1. This graph is going to have 3 turns, 3 changes from going up to down to up, stuff like that. X-intercepts and the behavior. The only way we're going to be able to get that is by factoring. So let's factor this. Remember, it was -x to the 4 plus 5x to the 3rd plus 6x squared. If it starts with a negative, you have to factor out the negative. You have to separate the negative. There's also a GCF here, so they all have at least 2 x's. So I'm going to factor out a -x squared. Remember, when you factor out a negative, all the signs change. So this is going to turn into positive x squared. That 5 is now negative, so -5x. And then -6. And then from here, I need to see if this polynomial in the parentheses is factorable. So I need numbers that I'm trying to find to multiply to a -6, but combine to make a -5, and that's going to work for us. It's factorable. It's going to be -6 times a +1. Now, normally, I write those numbers kind of floating on the top because I slide and divide, but I don't have to divide because there's not a number in front right here. So, in factored form, it is f of x equals -x squared, x minus 6, and then x plus 1. So when it's in factored form, we're still going to check the leading coefficient. The leading coefficient is still negative. Let's check the degree. Very important that you know how to find the degree when it's in factored form. To find the degree when it's in factored form, you add all of the exponents. So there's no exponent here. What is the exponent always understood to be when it's not written on something? Very good. So that's a 2. This x minus 6 is understood to have an exponent of 1. And this is understood to have an exponent of 1. When it is in factored form, you add the exponents. So what's 2 plus 1 plus 1? Just another self-check to make sure we're on the right track. And we are. All right. Time to identify the x-intercepts and their behavior. I am so glad I wrote that exponent because that identifies the behavior. So my first x-intercept, guys, I am just doing this one time. You take each factor and you set it equal to 0. So if I divide by -1 here, I get x squared equals 0. X is going to equal 0 here. X is going to equal a positive 6 here. X is going to equal a -1 here. Now, when I go to state what the x-intercepts are, they have to be in ordered pair form. So my x-intercepts are 0, 0, 6, 0, and -1, 0. But when I ask you to state the x-intercepts on this stuff, I'm never just going to ask for the x-intercepts. You always have to put the behavior to it. Behavior depends on if the factors repeat or not. So if I look here, that's a factor. That factor repeats twice. I know it repeats twice because there's a little 2 right there. So remember, for multiplicity, if something repeats an even amount of times, it's going to have tangent behavior. And I'm just going to put that t up there to remind me. Where did that t come from? It came from the multiplicity of 2. 2 is even. It's going to have tangent behavior. Both of these don't really have a multiplicity. I mean, you could say it's a multiplicity of 1, but that's silly. So anything without a multiplicity or a multiplicity of 1 is going to have straight through behavior. I'm just going to write some S's here to remind myself that it's straight through. All right. We have everything we need to make this graph. We have the end behavior, we have the intercepts, and that's it. We're ready to roll. So let me zoom out a little bit. I'm going to draw an x and y axis. And guys, when I draw this, I'm going to draw a pretty long x-axis because I'm going to spread out my x-intercepts. But my y-axis doesn't have to be like crazy. It can be kind of short, because all of my detail is really on the x-axis. So now that I've drawn my x-axis, now what I'm going to do is plot these points, and I'm going to label the behavior. So the first x-intercept is 0, 0, that's right here, and that is a tangent behavior on the x-axis. The next x-intercept is a positive 6, and that's going to go straight through from one side to the other. And then a -1, and that too is going to go straight through from one side to the other. The next thing I'm going to do is draw my arrows. It's down, down. On both sides of the graph, they go down forever. So it's going to be down here, and it's going to be down here. So now that I've drawn my end behavior and I've labeled my x-intercepts, I'm ready to connect and make smooth turns. I am not shown anything on this that's not required for full credit. You have to put the numbers, unless it's 0. Y'all, if you put something on the origin, you don't have to label that 0. Everybody knows that's 0, where it crosses the x and y axis. But you have to put the -1 and you have to put the positive 6. Alrighty, so here's how I graph polynomials. I start on the left, work my way to the right. On the left is always going to be an arrow, and it's going to go straight through. Then I got to turn and bounce off that tangent. Now I got to turn and go straight through to the other side. and go down forever. So that is the graph. I didn't have any problems connecting my arrows and connecting my x-intercepts, so I'm feeling pretty good. Remember, the number of turns is a great way to self-check to make sure you did this right. So remember, a turn is a change from up to down or down to up. So it's going up, then it goes down, that's one change. Look, it's going up again, that's another change. And then it goes down forever. That's 3 changes, which is what we had anticipated. So that is a great graph, a great sketch for this equation. Let's do it one more time, then we're going to pause for questions. So our next example is going to be in factored form. So you will be given stuff in factored form. The approach is a little different, but it's still pretty much the same. So our first example is going to be something, here we go. It is going to be f of x equals, and I'm not going to say this out loud because sometimes I misspeak and I don't want to say the wrong thing. All right, we're still going to find all those same things. So we're still going to identify the leading coefficient. We're still going to identify the degree because we need the end behavior. The number of turns is a great self-check, and we must have the x-intercepts and the behavior of the x-intercepts. All right, so when it's in factored form, sometimes you might have to do a little extra work. There's not a number in front of that, x. There's not a number in front of that, x. And there's not a number in front of that. So I don't have to work to find a leading coefficient. I just see the first number. The first number out here, right after the equal sign, is 4. That's positive. So if it's a positive 4, then I know it's going to be up on the right-hand side of the graph. And then let's go ahead and determine the degree so we can figure out the end behavior. If you have a different color, I would suggest using a different color if it's handy, because finding the degree is different when it's in factored form. To find the degree, you must add the exponent. You must add the exponents to find the degree. So, and it is just the exponents of the x's. So y'all, look, see that 4? It's understood to have a power of 1, and that's really nice that it has a power of 1. Well, we don't care about it. We only care about things that have the letter x. So this is going to be 2 plus 1 plus 3. So 2 understood to be 1 plus 3, that is going to be a degree of 6. Yay! We know 6 is even. Yay! We know the end behavior is the same. Also, from the degree, we get to determine the number of turns. The number of turns is going to be 5. And yay for us, we don't have to factor because it's already been factored for us. So our first x-intercept is going to come from this first factor. So that first x-intercept is -1, 0, and it's going to have a behavior that is tangent. How do I know it's tangent? It's repeated an even amount of times. My second x-intercept is going to be 2, 0 with straight behavior because it's not really repeated. It just has multiplicity of 1, so straight through. And my last x-intercept is going to be positive 4, 0, and that is going to have a change in concavity because that's repeated an odd amount of times. All right, so do I have my x-intercepts? Yes, I do. Do I have the end behavior? Yes, I do. That's it. That's all you need to graph a sketch of this. So here we go. I am going to draw an x and y axis. I'm going to start plotting some dots. So I have negative 1, 0 with tangent. I have positive 2, 0 with straight through. And then I have 4, 0 with a change in concavity. Now remember, your change in concavity is going to have a swirl. A swirl. All right, what else? End behavior. Okay, up, up. Not a big deal. Just going to do that. All right, here we go. So when I graph this, I'm going to start on my left. I'm going to bounce off this point because I told myself I need to do that. Now I have to turn and go straight down on that positive 2. But now I have to turn and go back up. Okay, so when I get to this 4, guys, I need to show like 2 turns the best I can. So it's going to go like that. And I'm not really good at graphing that, and that's okay because I wrote CC. Every time you write the words CC, or the letters, I guess I should say CC, that's 2 turns because it goes up and it goes down. All right, so let me just make my arrows match here because all right, the degree is 6. The turns are 5. Let's check the turns. Down, then it goes up. That's 1 turn. Look, here's another turn. Look, here's another turn. So that's 3. Anytime you write CC, that's 2 turns because it goes like that. That's 2 turns right here. So 2, 3, 4, 5. 5 turns, we're good. And that's graphed.